right, so both of these are just a little bit different than the ones that we've typically done. They still work essentially the same, but I've changed one thing or given you something that I don't usually give you, taken away something that I usually do give you. Okay, but in the end, there's still projectile motion problems, so they can still be solved using essentially the same set of steps we learned before. All right, so let's have a look at the one where we have the object projected horizontally, like at Head Smashed In Buffalo Jump. Okay, if you haven't been there, you should go check it out. It's actually pretty cool. Okay, but obviously the Aboriginal people of our area, this is how they used to hunt buffalo. Okay, before they had horses, before they had rifles and all of that kind of stuff, the best way to hunt buffalo was to spook them. Because when they're spooked, they put their heads down like this and they run forwards. Now, where are the eyes on the buffalo? They're on the sides. So when they're running really fast, they can see to the sides. Herbivores generally have their eyes on the side so that when they're eating, they can see their predators. Okay? You or I, if we bend down and look at the ground, we see the ground. We don't have really good peripheral vision out to the sides. Okay? But things that typically eat plants and eat grass typically have their eyes on the side. Now, the one drawback to that is for a buffalo, they're actually quite a ways over to the sides. It does create a blind spot in front of them. So if you spook them and you get them all running as a herd, and you keep distracting them from the sides, which is what they would do, okay, they would just keep making noise and throwing stuff at them from the sides, okay, you could run them off a cliff. Because, well, you're not going to take one down with a spear or a bow and arrow, okay, they're just too big. You could fill a buffalo up with a dozen arrows and it won't fall, okay. You would need to have something better than that, which is why, of course, buffalo have gone nearly extinct since the appearance of the rifle and the horse. It's a lot less sporting, okay, at that point. So they would just run them off the cliff. So here's what we have. Okay, we have the buffalo landing 75 meters from the base of the cliff. I don't know, I just made up these numbers. I doubt it's actually that far, but that's what I said. Okay, 75 meters. So we have our cliff. Okay, we have the buffalo running off the cliff and doing this. Okay, and hitting the ground 75 meters from the base. We're told the final vertical velocity, so VF, is 36 meters per second. Okay. We also know that the acceleration is 9.81 meters per second squared. And what else do we know vertically? The initial velocity. Remember, the buffalo ran horizontally off the cliff. That means that at time 0, it wasn't moving vertically. It was moving horizontally. So VI is 0 meters per second. Okay. From a horizontal perspective, I only know one piece of information, and that is the horizontal displacement, 75 meters. Right, that's it. So it wants to know how fast the buffalo was running. So it's wanting to know what V horizontal was at the time it left the cliff. If I'm going to get that, what other piece of information do I need? Time. Okay. Can I get time with my vertical information? Yes, and I don't need the height of the cliff to do that. I have VI, I have VF, and A. So T will equal VF minus VI over A. So that'll be 36 minus 0 over 9.81. That will give us our time. So 36 divided by 9.81. All right, so we're looking at 3.67 seconds. Okay, now I can figure out what the horizontal velocity was by going V equals D over T. So that'll be 75 meters divided by 3.67 seconds. Remember, we want to use all of our decimals. That's why I'm keeping that number in my calculator. Okay, and using all of them. All right, so that means that it was running at 20 meters per second, because we only have 2 significant figures. How important will significant figures be on your unit exam? Very. Like if your answer doesn't have them, your answer's wrong. Okay, 5-mark question, that's 20%. You don't want to lose that. Okay, so keep an eye on your significant digits on the unit exam. Okay, questions on that one? All right, so a little bit different, right? Most of the other ones I was either looking for the height of the cliff or something like that. Okay, this one asks for something a bit different. Number 2 also gives you a slightly different set of givens than I usually give you for a projected analytical type question. So it tells us that the projectile, the cannonball, is fired into the air at an unknown angle. And it does this. Okay? it tells us that it reaches a height of 78 meters. Okay. And it tells us that the horizontal velocity is 85 meters per second. It wants me to calculate this angle. If I'm going to have that angle, I need how many sides of that triangle? 2. Okay, I have this side already. This side here is 85 meters per second. So if I can get one more side, and I'm betting that VI is probably my best bet on that, okay, then I'll be able to calculate the angle of the launch. Okay, so here's what I have from a vertical perspective. I have the maximum height, and it's 78 meters. What do I know happens at the maximum height? It starts to come down. So how fast is going vertically? 0. Okay, so I have that piece of information. And I also know one more piece of information. Acceleration. Okay, with that information, can I get VI? Yeah. Okay, I'm still going to use this formula here. Okay, VF squared equals VI squared plus 2AD, or I could use this formula as well. D equals VF times T plus 1/2 AT squared, and I could solve for, minus. I could solve for T and then go back, but that's solving it in 2 steps. This will solve it in 1. Okay, so I'm going to solve for VI, because that's what I'm looking for. So it just means subtracting 2AD over to this side. So VF squared minus 2AD equals VI. So 0 minus 2 times negative 9.81, and it's crucial that you remember it's negative here, times 78 meters. And I got to square root it, right? Because that's VI squared. I didn't show you guys that. Okay, thought that number looked really big. Okay, square root that. And we've got 39.1198 meters per second. Okay, so that's VI. So now I know this side of my triangle is 39.11 meters per second. Can I now use that and the 85 to get the angle? Yeah, and I'm going to use tan because I have the opposite and adjacent sides. So theta will be tan to the minus 1, okay, of 39.11 over 85. Okay, so 25 degrees above the horizontal. Everyone all right with that? Okay, so a little bit different, okay, than what we've seen before. Okay, so let's have a quick look at number 7 here, guys. So we have an object thrown from the ground into the air at an angle of 40 degrees. Okay, from the horizontal at a velocity of 18 meters per second. Okay. Did you think the 18 was the horizontal?
Yeah.
Okay, yeah, it's kind of worded poorly that way, but it's 40 degrees at 18 meters per second, so the hypotenuse is 18. Make more sense now?
Yeah.
Okay, do I need to go through the rest of it?
No.
Probably not. Okay. I'll give it a little time, then I'll go through the whole thing anyway, but it's a wording thing on that question for sure. All right, let's have a look at the rest of number 7 here, guys. Okay, so we have 18 meters per second at 40 degrees above the horizontal is our projected velocity. Okay, question only wants to know how far it's going to travel horizontally. And so we have our vertical information and our horizontal information. Okay, right now, without any calculating, the only number I really know is that the acceleration vertically is negative 9.81 meters per second squared. So what I have to do is I have to find the components of the launched or projected velocity. V horizontal, which is the adjacent side, and VI, which is the opposite side. Okay, so that'll be a vertical piece of information. So to get VI, I'll go sine of 40 times 18. Okay, so we got 11.57 meters per second, and that's positive, because it's upwards. Okay, since this thing is going all the way up and all the way back down, VF is the same as VI, but negative. Okay, so now I have those two numbers. Horizontally speaking, I can calculate the horizontal component by going cos of 40 times 18. All right, so 13.789 meters per second. All right, I need to find the horizontal displacement. In order to get that, I need the time. Well, I can find the time using the information I have here on the vertical side. Time will be VF minus VI over A, so that'll be negative 11.57 minus 11.57 divided by negative 9.81. Everyone follow what I'm doing there? All right, so we're looking at 2.36 seconds as our time. That can come over here, 2.36 seconds. Now I can find D. Okay, horizontally, the object moves at a constant velocity, right? So this number here that I calculated doesn't change, 13.789 times 2.36. That'll give me my horizontal distance, which is what the question wants. So times 13.7887999. So it's going to travel 32.5. And the other one's giving us trouble. Right, that would be very much like what you would see tomorrow, but I would also ask what is the maximum height. For this one, the significant digits would be would be 3, 40.0 and 18.0. Both numbers I was given, 3 significant figures. Any other questions on that one? All right, so you got a few more there you can try. In a couple of minutes, I'll talk to you and remind you of what things you need for your unit exam tomorrow.